hold ourselves up a reach project. Scaffold. Okay, and this is going to basically scaffold up a base project. It allows us to use React through this, so set up a little web server also. And you can see we have our package.json. We can add some other libraries if need be. The next thing that we're going to do here is that we're going to call reaches init, and that is going to give us a base reach file and a front end for testing. Okay. So we'll see here that we have our index.mjs. This is our front end test runner file. And the index.rsh, that is our reach file where we actually write our contract. So I'm just going to move this to the other side here. And close this up also. Now, this is the base construct. We have something called a participant. I'll explain that in a little bit later. We're going to look at the test runner and see kind of how this works, because this is all we actually really need for base communication between Alice and Bob as participants in this role, and the communication with sending a contract and deploying a contract and seeing Alice actually have to pay some transaction fee for that. So I'm just going to add some code to this test runner here, and this is in the notes for this lecture. And you'll see here I have the gists for it. So what we're going to do here is actually compile out our first reach program. So all we have to do is just call reach compile. Okay, and now you'll notice that we have this build folder. And inside this build folder, this is where the actual contract resides. This is what you also put onto your web server. This will connect to either the Ethereum, Binance, Matic, or Algorand blockchains. And yeah, let's look at this. So this is the output. So you see here we have a definition for algo, and this is Algorand's TEAL, is transaction approval language. And if we go further down, we'll see that we have some bytecode for ETH, for an Ethereum or EVM platform. So the way that reach basically works is that it compiles down to the bytecode of the blockchain that it is going to be deployed to. Okay, so this amount of code that we see here for this communication between Alice and Bob, these are the representatives of that in their respective blockchains, languages. Okay. So now we're going to just basically run this out, and then I will go through each of these parts. You'll just see some basic communication. Okay, so you can see here that we have 2 instances running, and I'm hitting the Algorand blockchain because by default this actually hits Ethereum, so that's why I'm going to use that as an example more so. So you can see here is asking if we're going to be Alice. We'll say yes. Okay, it's asking if we want to create an account or just use a mnemonic. We're just going to create an account. And in the Bob scenario, we're going to say no. And we'll say yes to creating the account. And it's asking Alice if she wants to deploy the contract. We'll say yes. And we don't want to deploy the contract. And this is now Alice is going to get that contract information, and then we can we'll pass that over to Bob. So you'll see here that in our fall through, we're not doing anything. You see here that we have the Alice stuff and do Bob stuff, but it's just kind of falling through. But we can interact with it. So if we take this, the contract information, we can paste that in. And now you can see where do Bob stuff, and Bob's balance doesn't change, but Alice's does. And why is that? Because for Alice to deploy the contract, she actually has to pay the transaction fee. So you can see here that this is actually a real representation of a interaction between Alice and Bob in a consensus network. And in the next videos, we'll go a bit further.